If you're not sure, you should probably do it. Just keep your options open, you know. So.
What do I take after BC?
Calculus 3.
Where?
The U of A.
Okay.
We don't offer it here.
Okay.
They'll try to set you up with like a schedule where you could take just classes at the university in the morning or just the afternoon, so that's like easy for you to switch back and forth.
Okay.
Or you could do AP Stat. Some people do AP Stat, but.
What? Oh wait, you have
too hot.
Oh, they're making you work.
Except for Wednesday, we go to Agri. It wasn't too hot that day.
Did you?
I'm ready for the weather to cool down a little bit.
Oh yeah.
Hey, Reese, that's
Me too.
I
I'm sick of being sweaty every time I drive home at.
I feel bad. I feel bad, but like,
Thank you.
can't turn left when it's green, especially there. That's a rough spot to turn left out of. That's
That's how I gave it to you.
I know, I saw it and then put it back.
Okay, well now you gotta put it back over there.
You're making a lot, right?
good thing. Where does it go? We're gonna put it on the bed.
You got 5 minutes.
Yeah, I felt bad. She was like, I'm not gonna show me. And I was like, they're gonna be happy you're okay.
New car. It was a new car.
Wait, that was a brand new car?
Not brand new, but new. Like they just bought it. Like,
Well, it's cooked now.
okay, I'm sorry, but don't let your buyers in a new car, especially if it's their first one. Like everybody knows.
Yeah, I don't know, but that was really unfortunate. I was about to back out. They're like, no.
Instead of learning to ask questions.
Do we have to do number 8 or just?
Allie, are you joining Costa this year? Wait, when's the first meeting? 13th. Also, please show up because you'll get one of these. Yes. We still have like, I don't know, over 10 boxes left. Because people that pick up their boxes, yeah.
There is an assignment I'm asking y'all to turn in. You might want to do that before the room's really.
Easy. Forget it. Wait, so we go. Yeah, I just had like Geology Clover Mountain. Emerson and I make Clover. Can you see it? Are you guys doing your way? Huh? Yeah. You're just going over it. Whoa, that's cute. Cute.
I was in Walker this morning. It was sort of a good day. I just it's so sorry.
Oh no, yeah, we talked about that. We talked about that.
Change the Spanish. No, I asked him. I just like, yeah, I like Spanish. I like Spanish.
And I was like, this please don't be about me.
I like
thought you said you were about to get a
I'm worried everything. Turn off these phones right out. Sorry.
Okay, the only assignment I'm asking for today is number 7. If you turn number 7 in the Google Classroom, you're done. But if you didn't, make sure your name's on it and come throw it in the basket real quick. I need that before we start class. If you give it to me later this class period, it will be late. And that's, I tried to encourage you not to do your homework in class because then you'd be missing something else. So go ahead and give me what you got. And you should get out number 8 from your binder. We worked on number 8 last class.
I need
But most people did not finish number 8 in class, so I'm guessing that you may have a question or two.
I had trouble with one problem. Will I get half credit for not having the one problem solved?
Yes,
I will.
We did that one together in class.
Okay.
But remember, you can get half your points back by just doing the one question. So as long as you don't make a habit out of it, it shouldn't affect your grade by the end. 15. Angel. Angel's here. And Brendan. Okay, last call. Any other 7s? Okay, I should get those back to you. All right, so again, since you didn't have time to finish assignment 8, and so therefore you probably found some that you struggled with, I want to give you a chance to ask questions from number 8. Then we will review a question type from a few classes ago for number 9. You've already seen that one. I just want you to practice it. And then number 10 and 11, we'll talk about the notes and a few examples. But then at the end, I will ask you to only finish up 9 and 10. You won't have to finish up number 11. So from assignment 8, which of these questions did you want some extra help on?
Did you do 31 or 28?
31 or 28? Well, it doesn't matter to me. Which one do you?
Let's start with 28.
Okay. So starting with 28, all of these questions really fit into one of two things. You'll need to kind of catch this as you go along. If you're doing a limit as x approaches infinity or negative infinity of a big fraction like this, you should just be applying the 3 horizontal asymptote rules. If you're trying to take the limit of something that's not a big fraction, a rational function, then you need to be trying to plug this in, and then you need to try to think about how this is going to change. So if I take the number 2 and keep multiplying it by a bigger and bigger number, thank you. I need your number 7. Or, yeah, number 7 if you didn't put it in Google Classroom. So 2 times a number that keeps getting bigger is just going to keep getting bigger. And then sine, because the sine graph looks like this. Oh, it does not look like that. It looks like this. So you see how it just keeps bouncing back and forth between 1 and -1. So if you just keep going forever to the right, it just constantly just keeps changing, and so it never gets closer and closer to one specific y value, so we would say does not exist. It's got to approach the same thing. Okay, somebody else have another one?
35.
35. All right. Now, to be honest with you guys, I did 35 yesterday for my third period class, and I did make a mistake on there, so I will point that mistake out to you because it's easy for me to make that mistake. It might have been easy for you to make that mistake as well. So first off, what I did is I did these two parts separately and thought about vertical asymptotes. Vertical asymptotes are going to occur when you take a number other than 0 and try to divide it by 0. We can't divide by 0, so as you get close to that, that's when you get those vertical spikes in the graph, the x equals equations. So I did that for both of these, and I found that this top one has a vertical asymptote at 1 and -1. And this one, e to the x never equals 0. So that one doesn't give any others. So I narrowed it down to these three choices, I'm sorry, these two choices, where x has to be positive or -1. But what did I overlook there? Do you see what my mistake was? Yeah, what you got? Right, so this right here, this one, this top one only exists when x is greater than 0. So -1 doesn't make sense. If you're not paying attention to that, again, you're going to think x could be positive or -1. But this function only works, it's only defined when x is positive, which is not when x is -1. So it's actually not these two. And honestly, if that's all that you thought about, there's only one of them with that possibility. So that's enough to stop there. There's only one that even had that as an option. But to me, that's pretty tricky. So I would highlight and put a star maybe by that. That way, if you look back at it, you'll remember why it wasn't plus or minus 1. Okay, a couple others. Somebody who's not asked a question first. 26. 36. Okay. 36. And now again, I feel like I've probably said this, but just in case I haven't, what I really like about some of these worksheets, you can see when you get to the end and it says test prep, these are all real AP questions that have been asked at some point. So it gives you an idea of like the difficulty level they expect you to be able to do. Okay, to work question 36 though, I've got this insanely complicated looking function. That doesn't mean that the calculus or the algebra should be harder, but they are trying to confuse us with this. So the fact that this is a big rational function, the function is one big fraction, and it has a horizontal asymptote of 2, that gives me a lot of information because you can have 3 types of horizontal asymptotes. It could either not exist if the degree of the numerator is bigger, it's y equals 0 if the degree of the denominator is bigger, and the only time the horizontal asymptote could be something else is when you do leading coefficient over leading coefficient, and that's when the degrees are equal. So I look through here, and sure enough, it looks like the degrees are both 3. And so if I do leading coefficient over leading coefficient, the coefficient of x cubed in the numerator is -a, and the coefficient of x cubed in the denominator is -w, and that's supposed to equal 2. Leading coefficient means the number that's being multiplied by x with the biggest exponent. So with that information, I know a divided by w is 2. So if I can now figure out a or w, and I can finish this question. So the next piece is it has a vertical asymptote of x equals 0. And this came up in the last question. Vertical asymptotes are when you try to divide by 0, as long as it doesn't also make the numerator 0. How did we do that part? Okay, I don't remember how we did this one in the other class. Anybody got a hint for us? Okay, let me see what I did yesterday. Oh. I see. It looks like I just plugged in 0 for x. So I'm guessing since, yeah, let's switch back. All right, since it occurred when x equals 0, I guess that makes sense. I just plugged in 0 for x. I don't know what I was thinking. So if I plug in 0 for x here, this becomes e to the 0, and anything to the 0 power is 1. If I plug in 0 here, this all just goes to 0. And I'm left with w equals -1. Plug that back in over here, which means a equals what? Okay, and now that we know a and w, to get our answer, they want us to subtract those. W minus a would look like this, which should come out to be 1. So I'm applying the same old vertical asymptote rules, the same old horizontal asymptote rules, but the way they made this question harder is, one, you just didn't do one of them and that's your answer. You still had to subtract at the end. And of course, they gave you a function that if you don't know what you're doing, you can't just kind of wing it. There's too much going on there. You have to know, if I've got a horizontal asymptote that's does not exist and it's not 0, then the degrees must be equal. And then you start focusing in on, okay, the degrees are equal, so leading coefficient over leading coefficient, that's supposed to equal 2, and then you can kind of start moving forward at least. If you really dissect the question, at the end it should be the same math skills. But on face value, the first 10 seconds or so, it often seems like something we haven't done yet. But that will get easier as we practice those. Okay, did anybody have something more specific about 36 while it's still up there? Okay, one more chance. Anybody who has not asked a question today have another? Okay, anybody who has asked a question have a second one?
Did you do 34?
Sure, 34. Which one of these functions have both a vertical and horizontal asymptote? So, horizontal asymptote, we talked about those rules a lot last time. So, if the degree of the numerator is bigger, it doesn't have one. But if the degree of the denominator is bigger, it's y equals 0. And if the degrees are equal, it's leading coefficient over leading coefficient. So, that's not the case for this. Honestly, the best way to know this one is to kind of remember what the graph looks like. We do tangent graphs in pre-cal. There's no horizontal asymptotes. It's got plenty of vertical asymptotes, but no horizontal asymptote. Choice C has a horizontal asymptote at y equals 0 because the degree of the denominator is bigger. E has no horizontal asymptote because the degree of the numerator is bigger. D would be y equals 0 because the degree of the denominator is bigger. And on A, we can't really compare the degrees here, so the best that I could do is try to plug in infinity and negative infinity. If I plug in infinity, I believe it should go to 1, and if I plug in negative infinity, I believe it should go to 0. So those aren't going to the same number. So sometimes we say that's not a horizontal asymptote, but I think that's probably fine too. Okay, but for vertical, this is when you take a number other than 0 and try to divide it by 0. So if I put 0 in, I have to think about, can this denominator ever equal 0? So is that true for C? So x squared plus 2, does that ever equal 0? So this has no vertical asymptote. Well, I can already throw out E because it didn't have a horizontal asymptote. What about D? Does x squared minus 2 ever equal 0? It does. So they don't even care for us to tell them what it is. It's just which one has both the vertical and horizontal asymptote. That has to be D. It has a horizontal asymptote of y equals 0 because the degree of the denominator is less than the degree of the numerator. Oh my gosh. And it has a vertical asymptote because there's a number that makes you divide by 0 that doesn't also make your numerator 0. Is that enough? Okay. Anybody else for one more question? Anybody that asked one earlier? Okay.
31 possible.
Is 31 possible?
Or, I mean, like, can we go anything?
Well, I mean, you checked your answer, right? Okay, 31. Which one of these grows the fastest? Now, to me, I can narrow some of these down pretty quickly because I understand how different function types grow. In fact, that's a much bigger concept in BC. But what you might consider, if you struggled with this question, is in our notes where they were trying to push you into a strategy. If you don't know how these compare, which ones are bigger or smaller, you can just do something like maybe plug in x equals 1, get a value, then maybe plug in x equals 10, get a value, and then when you've got a couple values, you can start to see how those compare. But in general, notice exponential functions grow way faster than polynomial functions. If x is big enough, those will outpace those. So this guy is an exponential decay, so it's growing super slow. This is a polynomial function. Now, of course, u to the 100 is going to grow a lot faster than u squared. And u is just a different variable. If that bothers you, you can change all the u's to x's. X to 100, sure, that grows really fast, but it's still just a polynomial. It's not going to grow near as fast as an exponential function. So that can't be the fastest. And then let's look at these. Let's compare this one to this one. This is 4 to u, and this one has an e to u. Which one of these bases is bigger? 4. And the bigger the base is, the bigger the exponential, the faster the exponential function will grow. So this times 200 is going to help, but when you start talking about u values of 1,000,000, that times 200 is just not important. The bigger base is going to rise faster than the smaller base. And then here, if I compare these two, this has a u to the third, so 3 to the u. Compare that to 4 to the u. The 4 to the u is going to grow faster than this. And then even with this, that makes it grow a little bit faster. This is just polynomial. So the answer should be C. But again, just to kind of, let's say on a test, I've not seen many of these question types before. But let's say on a test, you can narrow it down to a couple of them. What I was trying to say about that table is, you could plug in 1 for u to part C and part E. This would be 3 plus 1, which would be 4. They're both at 4 when u is 1. But if you go out enough, sometimes 1's faster at the beginning, but not faster overall. So sometimes you have to go out a few. But if I do u to the third, 4 to the third would be 64. 3 to the third would be 27, plus 3 to the third, which is 27, and this is 54. So you can see it doesn't take but just a couple u values for this one to be faster than this one. So worst case is make the table, plug in a couple numbers so that you can visually see how they grow if you had to. Yep. Okay, so I am not taking this one up today. Not that you shouldn't have it finished, but again, you guys already turned in assignment 7. I don't want you to get up to turn in another assignment. But I will probably ask for assignment 8 next class, so if you accidentally didn't have that one finished, you get a rare opportunity for a little more time on that before it's due. Okay, next up we're going to review on assignment 9. I had you pick up assignment 9 last class, so that's in your binder. We just didn't have time to get to it. But now we've got time to get to it. So find that in your binder. All right, so assignment 9 has 10 questions on it, and I'm actually going to do 4 of these as a quick little reteach for you. So we talked about this a couple classes ago. A couple of these question types you've got a bunch of practice on. A couple of these question types you did not get enough practice on, which is why I gave you this for some extra practice. So you're welcome to follow along with me. I'm going to go over one of each of these. And then when we get to the second half of class, this will be the first thing that I ask you to go back and finish up. So the first one I would like us to talk about together is number 2. So when we do these limit questions like this, what was that technique that we always have to start with? Right, just plug it in and hope that you don't get 0 over 0. 0 over 0 is where you got to do more work. Anything else you should be finished. Some questions can be this quick. Okay, everybody okay with 2? Okay. Then the next thing we did was we talked about, here's number 7. Okay, all I've got to do is direct substitution. But on question 7, we plug in -1, -1, -1. We end up with 0 over 0. So this is certainly going to happen to us a lot. This is the one we have to dig in a little bit deeper. So we've got a few different strategies to use that I want you to practice on this one, on this worksheet. But what did I say was the most common way to deal with 0 over 0? Right, factoring. So try to factor the numerator, try to factor the denominator. If something cancels, then you can just plug it into what's left over and then you're finished. Does that look like -4 to y'all? The answer to this is -4? Very good. When all your numerator gets canceled out, it's still a 1. Be careful with that. So direct substitution, 0 over 0, factoring is the most common way to deal with it. But sometimes factoring is not enough. So then we looked at a question like number 1. Again, the first part of this question and the last part of this question are the same. It's just a little middle piece that's different. You still start with direct substitution. You hope you don't get 0 over 0, but if you do get 0 over 0, consider factoring first. Neither of these factor, so we need to try something else. So specifically, when one of these have a square root in them, what was the method that we used to move forward?
Conjugate.
Good. Multiplying by the conjugate of the one that has the square root. So sometimes you want the conjugate of the numerator, but this time we wanted the conjugate of the denominator because the denominator had the square root. Now, make sure you're multiplying the top and the bottom by the same thing. If you don't do both, you're going to be confused why it's not working out. And if you're not multiplying the same thing on top and bottom, you're multiplying something other than 1. Now, to be fair, you did get a handful of practice on this because I had you do this on Khan Academy. But to multiply fractions, multiply your numerators together to get your numerator. I'm not going to bother to FOIL those. And then when you FOIL your denominators, because this is his conjugate, it's going to simplify nicely. So you could do the first part of FOIL, outer part of FOIL, inner part of FOIL, and last part of FOIL. But every time you multiply something by its conjugate, the outer and inner part of FOIL are going to cancel anyway. And now the question should finish like the others. Something cancels, now direct substitution works. That's where they're coming up with an answer of 2 for question 1. Again, I know you've practiced this one some, but a little bit more practice would be nice. When we get to the test review, I'm not going to put like 20 of these on the test review because hopefully you've practiced them enough. Did you have a question? Okay. Everybody okay with number 1? Okay. Then the last of them, and really probably the main reason why I'm pushing you to work on this worksheet, is ones like number 3. I did one of these for you in your notes, but I didn't have any practice for you the other day. So again, the end of the question is going to be the same. The approach at the start of the question is going to be the same. It's just a couple steps of algebra in the middle that's going to be different. So I'm still trying direct substitution. I'm still hoping I don't get 0 over 0. If I do get 0 over 0, I'm still thinking factoring first because that's the most common. Next up, I'm thinking about conjugates, but there's no square roots in here, so it's probably not conjugates. So in this case, we need to algebraically fix this. I don't like these small fractions within a big fraction. So that's what we call a complex fraction. So there's several times in mathematics you need to know how to simplify a complex fraction anyway. Just happens, one of those cases just happens to be limits. But basically, we're going to multiply everything by 3 and multiply everything by x plus 3. The reason we multiply everything by 3 is to make these smaller denominators cancel and go away. And the reason we multiply everything by x plus 3 is so that those two cancel and those smaller denominators go away. So usually you're not finished. Make sure you distribute that negative. That makes the x and the plus 3 negative when you distribute that. But we're very close. So again, if you understand how to go from fractions within a fraction to not having fractions within a fraction, then you can do this question type. There's not anything else special or unique about it. Okay, and then in the denominator, 3 minus 3 goes to 0. Once you do that, combining like terms, now something cancels, and now direct substitution should be fine. Looks like we should get negative 9, which is what they got. So again, I just multiplied everything by the small denominators, 3 and x plus 3. They got rid of the small denominators and rephrased the question in a way that I felt more comfortable with. Okay, so there's one of each type that will show up on this number 9. So here in just a little bit, I will ask you to come back and finish this one up. So you've got 6 more of these. Some of them will be just direct substitution. 1 or 2 of them you'll need to do the factoring. 1 or 2 you'll need to do the complex fraction, and 1 or 2 you might need to do the conjugate. So that's not new. That's just extra practice so you feel more comfortable there. Okay, but before I give you time to do that, I would like to go over the notes for assignment 9 and 10. I'm sorry, not 9, 10 and 11. And 10, I will actually ask you to finish up. So we'll do the first part together, and then that will be another part I ask you to practice. We'll do the notes to number 11 today, but not any of the practice of 11. Okay, this worksheet is specifically about limits of properties, or properties of limits. And to be honest, you've been using some of these already. Most properties of limits are very, very intuitive. Adding, subtracting, multiplying, and dividing all pretty much work the way people expect them to. So just like x plus x is 2x, if you have the limit of something plus something, you can work these separately. So you can work the limit of the first part, then you can work the limit of the second part, and then just do whatever it says. If it says add those numbers together. If it was subtract, you subtract them after you do them individually. Multiply, multiply. If it said divide, you would divide those two numbers. You can just work the terms separately and then do the mathematical operation behind them. So notice too, by the way, these two are exactly the same thing. So anytime you take something and add itself to it, it's like you've got two of them. So if you'd want to write it that way, you could. You got two of the same thing. Okay, so with our properties, we can do questions that look like this. And again, this looks pretty crazy. It's a little wild. But since we can do these at one piece at a time, it's going to be very manageable. So I'm going to do the limit of f of negative x. And then it says plus. So then I'm going to add. I'll do the limit separately of g of x over 2. Okay, and then we need to use this table. So for this limit, if I do direct substitution, this would be f of negative 1. And you can look at these two. It's kind of hard to tell which one they're talking about, but it would be this one. Because if you do direct substitution on this, this is f of negative 1 also. So f of negative 1 is 2. That part is 2. And then it says plus, so I'm going to add. And then this one, the limit as x approaches 1 of g, and then divide that in half. The limit as x approaches 1 of g is 6, but divide that in half, which gives you 3. 2 plus 3 should give us a final answer of 5. So it doesn't matter that it's got a bunch of different moving pieces there. We get to work them separately and then do arithmetic at the end. So add, subtract, multiply, and divide, you probably don't even need to study. Those just work the way people assume that they would work. The one that does not work the way people assume, or some people guess it, but not many people, is when you want to take the limit of a function plugged into another function. So make sure you put in good notes here, because you may want to look back at this one in the future. You only do the limit of the inside part. And then you plug that into the outside part. So you only do the limit once, and then that gets plugged into whatever this little outer function is. So we could do the limit as x approaches 4, which would be 1. It approaches 1 from the left and from the right. And then f of 1 is talking about something totally different. F of 1 is not even a calculus topic. This is talking about a point now. It's saying that when x is 1, what is y? So now you go over here, and it looks like that is at negative 1. The answer to that question is negative 1. So limit of the inside, plug it into the outside. Limit at the start, point at the end. So not hard to do it all, but obviously, you know, it's a little bit of practice before it's going to stick in your brain. Okay, here's another pretty crazy example, and then we'll review piecewise functions that we did a few classes ago. So I don't know if I've ever seen a question like this as tedious as this one on the actual AP exam, but you can see that it's not really any harder as long as you understand that you can do these individually and then do the arithmetic afterwards. So, for example, the limit as x approaches 5 of h of x is right here. That's 5. I missed this the first time with my 8A class because I missed these parentheses. So be careful that there's parentheses there. Then I can do the limit as x approaches 5 of f of x, which is right up there in the table, plus 2 times the limit as x approaches 5 of g of x, which is also up in the table. And then finally, minus h of 5. H of 5 is just a point, and there's the number. So all that's left for me to do to finish this question is the arithmetic. It said times here, plus here, times, and a minus. So times, plus, times, and a minus. My answer is going to come from 5 times 4 minus 3, which is 20 minus 3, or 17. So a little more tedious, but it shouldn't be any harder. Okay, the other thing that you'll need to practice on this worksheet is something else we did the other day in some notes, but I didn't have a handful of questions for you to practice, and you need to be able to practice these. So this one is just getting you to think about the limit from the left, the right, and then the limit. So just be sure that you're looking at these carefully. From the left is when x is smaller than negative 5, so you would plug that in here. You get the square root of 16, which is 4. If you want to know the limit as x approaches negative 5 from the right, that's when x is slightly bigger than negative 5, so you'd plug it into the bottom. That reduces to 1/10. And whether you're talking about a table, a graph, whatever, for this limit to exist, the limit from the left has to be the same as the limit from the right. Since those are different, that limit does not exist. So, other than maybe the notation, there's not really much calculus going on here. They're trying to get you to slow down and think about which one of these pieces makes sense to plug it into. Okay, last one for this assignment, and then we can move on to the last assignment I want to do together. So, piecewise functions can have more than 2 pieces. They can have as many pieces as they want. 2 and 3 piecewise functions are the most common. But the limit as x approaches negative 1, unlike the last little group that pushed me towards that, I would have to slow down and think about the limit from the left is when x is less than that. Oops, which would be 3. The limit to the right as x approaches negative 1 would be right here, where x is slightly bigger than negative 1. It is also 3. So what's the answer to this question? One more time. 3. If the limit from the left is 3 and the limit from the right is 3, then the limit that does not designate a direction would also be 3. Okay, B only wants E from the right, so should I plug, it's pretty obvious not to plug it into the top. The top doesn't look like it has anything to do with E, but from the right, should I plug it into the middle of the piecewise function or the bottom? Bottom. From the right is when x is bigger than E. Do y'all still remember the direction of the inequality sign stuff? How did y'all learn that in grade school? Alligator eats the bigger side, right? Or you can do bully points to the smaller side. So just make sure that you don't mix those up. So I plug that in, you get something that looks like this. This is perfectly fine for a free response, but it's probably not how the answer is going to look as a multiple choice, because we can simplify this. Do you remember what we can do with exponents on things that you're taking the log of? Okay, it can bring down out front. And the natural log of e is something they expect you to remember. So your answer ends up coming from 3 times 1. If that was a multiple choice question, the answer would probably be 3, not natural log of e to the 3rd. And to be fair, that's one of the hardest things about calculus. They throw random unit circle questions at you, random logarithm properties. There'll be a couple of geometry formulas we have to reuse. Pretty much anything you've ever learned in a math class will make an appearance at some point in calculus. So, okay, and then finally the last one, the limit as x approaches e Well, I already did that from the right, so now I just need to think about it from the left. So if I plug that in up here, I get 26 minus 5e squared over 7. So the limit from the left is this mess, the limit from the right is 3. So if the limit from the left does not equal the limit from the right, the limit does not exist. Doesn't matter if you're talking about a graph, a table, or a piecewise function. The limit from the left has to equal the limit from the right for the limit to exist. Okay, so this will be the second of 2 things I asked you guys to go back and do here in a bit. But we've got one more thing I want to talk about, but you will not be on the hook for doing any of this until next week, other than just follow along with me. So the last thing I'd like to introduce you to before you can just get some practice under your belt is this definition of being continuous, definition of continuity. We talked about it being continuous last time when we talked about IBT. But truthfully, about 95% of calculus only works if you're talking about continuous functions. If your graph's jumping around all over the place, or it's got random holes in it that we don't know about, or random vertical asymptotes that we don't know about, most calculus theorems just don't hold up. It has to be semi-predictable. So most everything we talk about this year will be referring to being continuous. So on your AP exam, they expect you to know this 3-part definition of being continuous. You can't just say, oh yeah, that's not continuous because the lines are not connected. You've got to refer to it in a mathematical way. So if I want to know if it's continuous at some generic value c, there's 3 things that has to happen. You better make sure you have a point there. If there's no point there, you've got a hole there. If you've got a hole there, it's not continuous. You also don't want your graph to just randomly be jumping at that point. So we need the limit as x gets close to that to exist, which of course implies, you should know this now, that the limit from the left is the same as the limit from the right. If that's not true, it might be approaching 0 from the left and 5 from the right. That big jump there is a break in the graph. It's discontinuous there. And then the third one's usually the hardest one for people to recognize or make sense out of. Does anybody happen to remember it from pre-calculus? Okay, then let me show you an example. I can make an example that makes both of these true, but it's still not continuous, and then hopefully that helps you understand this one. So C, I need to have a limit, so it needs to approach the same thing from the left and from the right. And then the first one is what? What's the first part of the definition? Okay, so I'm going to put the point right here. Is that continuous? No. So having a point and having the limit exist is not enough. The point has to be right here to like secure this continuity here, to make sure that this is a nice smooth thing. So whatever the point is, whatever the y value is, needs to be the same as the number it's approaching. The same as the limit. So there better be a point, the limit has to exist, and the point and the limit need to have the same value. So if we are proving that something is continuous, we will have to state all 3 of those things for that number. If we are proving that something is not continuous, we just need to state one of those that's messed up. Okay, so if we look at this, is it continuous at x equals -1? Well, I'm just going to basically start off by kind of assuming that it's continuous. I'm going to start with the definition. Is there a point when x equals -1? There is. Right here it says when x equals -1, you can plug that into here. So -1 plus 2 is 1, but the main thing is just that it exists. I don't really care that it's 1 yet. There's a point there. The second part of the definition says that I need to make sure the graph's not jumping around. Make sure the limit exists. So the limit as x approaches -1 from the left, from the left, would be, just plug in 1 into this, 1 minus 2, 1 plus 2 plus 1, which would be 4. And the limit as x approaches -1 from the right would go in here. -1 plus 2 would be 1. Now, isn't that a problem? So, if it's 4 from the left and then 1 from the right, again, I'm not going to sketch this accurately, but what it's saying is when x is -1, it's approaching 4 from the left, and then at an instant, it's down here at 1. This is an obvious break in the graph. You can't jump those y values. So now I have figured out, oh, okay, is it continuous? No. And my justification, I just need to state the one thing that was messed up. The limit as x approaches -1 from the left is not the same as the limit as x approaches -1 from the right. I don't need to state the things that are true. If I'm saying it's false, I just need to state what's messed up about it. Now, I'm not to say that you guys can't explain this in words, but I can tell you 99 times out of 100, students that try to explain this in words don't do it comprehensively. What I mean by that is, like, their sentence or two, they're creating like some scenarios that match what they say, but doesn't always say that. It's better to stick with the definition and the math symbols. Okay, but then number 2, again, I'm going to just assume that my answer is yes, and I'm going to start to go through it. If I plug in 2, looks like it could go in here, and I would get 4, so that obviously exists. There's a point. I know the next thing is the limit has to exist, so I'm going to think about the limit as x approaches 2 from the left. That would be 4. I'm going to think about the limit as x approaches 2 from the right. That would be 2 squared, which is also 4. So the limit from the left equals the limit from the right. Second part of the definition is true. Okay, and then the last part of the definition, it better have a point and it better have a limit, but to make sure all of those are nice and neat and connected, you have to make sure that the point's value is the same as the limit's value. So, since all 3 parts are being met, I can confidently say it is continuous at x equals 2. If we graph that piecewise function at x equals 2, there would not be a break there. Because I know it's not a hole, there's a point. I know the graph's not jumping because of the limits, and I know the point's in the right spot. So no, to state the thing that's wrong. Yes, you have to state all 3 parts. Okay, so another thing we'll practice on Tuesday is the types of discontinuity. So there's a couple types you need to know. One of the types is not very intuitive with its name, but the other 2 are pretty intuitive. So notice on question 2 here, well, first off, 3x plus 1 is continuous. Also, x over 2 minus 1 is continuous. I'm concerned about there being a discontinuity when it stops being this function and starts being this function. So I really only worried about at x equals 4. I can't just magically go from this function and then drop down to this function and expect it to be continuous. So I will think about the limit as x approaches 4 from the left. I'll be plugging that in up here and I'd get 13. I'm going to think about the limit as x approaches 4 from the right, which would plug into the bottom. And you'd get 4 over 2 minus 1, which is 1. So what happens when it's approaching 13 from the left and 1 from the right? way up here to the left and then way down here to the right. It's definitely discontinuous, right? But they stated that in the directions. What do you think it's called if it's way up here and then goes way down here? Very good, jump. Your whole graph is jumping. It's called jump discontinuity. That's the type. Now, if it's just at an instant, like a single point, that'll be something different. But if your whole function's being shifted at an instant, it's called jump discontinuity. Okay, the other one that you need to see that's not on this one, I don't know why, but the other one that's fairly intuitive is when you have asymptotes, specifically vertical asymptotes. So this is discontinuous at this value. Over here is going to infinity. Over here is going to negative infinity. So what would you guess the type of discontinuity it would be called? Not all. Oh, no, not whole. There's no hole here. This is an asymptote. Close. It's a vertical asymptote, but I'm wanting to know what type of discontinuity. This is called infinite discontinuity. If the graph's going to infinity and negative infinity, that's referred to as infinite discontinuity. So, as a multiple choice question, students usually, I don't think you really need to study that. I think you'll remember infinite is going to infinity. Jump, the graph is jumping. The one I'm actually worried about are next to the last question we're looking at together on the board is a question like number 3. So again, the top piece is continuous, the bottom piece is continuous, and the middle piece is continuous. It's going to be discontinuous when it's handing off from the top to the middle or from the middle to the bottom. So I'm going to think about where is it as it approaches -1 from the left and plug that in here. That would be 0. Does that look right?
What did you make it
1 minus 2 minus 1 -2. There we go. Sorry. I can do the calculus, but not so much the arithmetic. So. Okay, mentally, at least, I'm thinking about, well, what's it getting close to from the right? And then I plug it into here. -1 minus 1 is -2. So wait, if it's approaching -2 from the left and -2 from the right, doesn't that mean it's continuous? Right, there's 2 other things that have to happen. There has to be a point at -1. Is there a point at -1? Yep, it's right here. When x equals -1, y equals 5. The point's there. But notice that the limit doesn't equal the point. So it's discontinuous because of the last part of the definition. And physically, what it looks like is as x approaches -1, it's approaching -2 from the left and from the right. But at that moment, it has a point up here. So that piecewise function might look something like this. He's approaching the same number from the left and right of -1, but when x is -1, y is all the way up here. This is not called a jump discontinuity. It kind of looks like the graph jumps, but it's just for an instant. It's not that the whole graph jumps, it's just that this one point jumps. And somebody second period today asked a great question. Whether this point is here or not doesn't matter for the type of discontinuity. It would be great if they called this whole discontinuity, because you would remember it because it has a hole in it. But unfortunately, it's not called whole discontinuity. It's called removable discontinuity. Personally, if I was you, I'd put a star by that. Maybe for our first quiz, but also specifically in March or April when we're reviewing for the AP exam, you don't remember what removable discontinuity it is, it'd be nice for you to be able to find that in your binder. So, if the graph is jumping from like 1 to 13 at an instant, jump discontinuity. If your graph has an asymptote, it's going to infinity and negative infinity, we call it infinite discontinuity. If your graph is discontinuous because it has a hole in it, we don't call it hole discontinuity, we call it removable discontinuity. So that's the one that you probably wouldn't guess. Okay, and then finally, h of x is this piecewise function. Let's go try to figure out how to figure out what k would have to be to make sure that it's continuous. So k is just some generic number here. So like I've said on several questions now, this top part's continuous, this bottom part's continuous. But they may not be continuous when it hands off from the top function to the bottom function. There could be that disconnect, there could be that jump thing going on there. So I need to make sure that they're at the same place at the same time when x equals -2. So I'm going to plug in x equals -2 into both of these. So it looks like the top piecewise function has a y value of -2, and the bottom piecewise function has a y value of -8 plus k. You just have to get out. I know that's uncomfortable not having this as a number, but this is what they love to do to you on the AP exam. You have to get over that. How do these things need to compare to make sure that this is continuous? They should be what? They should be equal, right? If this has a y value of -2, I need this to have a y value of -2. I need them to be connected. So really I just need to set these two things equal to each other and solve a one-step equation, and I know what k is. So again, I told you you're going to get sick of me saying this, but notice in this question, if you look at my work that I wrote down, the math, the algebra, the equation solving is real basic. It's all Algebra 1 level stuff. But the calculus almost doesn't even show up on here. The calculus is understanding for these to be continuous, the y value of this and the y value of this have to be the same at that time so that you understand to plug in that value and set them equal to each other. Okay. So again, that's just a little bit of an introduction there so that we can hit the ground running with that next class. But to be clear, number 11, you don't have to work any more of that at this point, not till next week. The two things I need you to get some more practice on, please do assignment 9 first. It's got the answers on the bottom. I did 4 of the 10 for you already, and the other 6 are the same type as one of the 4 I did. So you've got an reteach example down on that paper already. And I need you to work through assignment 10 on the properties of limits. So finish 9 and 10, preferably in class, but if you don't have enough time in class, that's fine, but you need to finish that up for homework, please. If you give me just a few minutes to look over these homeworks and get the grades put in so I can pass them back, and then I will offer to come around and help out if you're stuck with the math. In the meantime, you guys are encouraged to work together and help each other out. Again, the answers to number 9, worksheet 9 are on the bottom. The answers to worksheet 10 are on my website. I would highly recommend that you check your answers as you work through those. When you finish that one, just throw it in the basket. Or whatever you do. It doesn't have to be today, as long as it's before this.
Because I originally
For G? Yeah, but look, see, if you plug 3 into this,
had. Oh, then it becomes
then it's
negative.
G of -3.
I know.
I don't know if you have the best signature or the worst signature.
I think it could be both, especially in the fancy. It's kind of hard to read though.
It sounds like you're implying that it sucks.
Yeah. I didn't say that. Surprising. Okay, I got all those passed back. So I can offer to help out a little bit here. Looks like we've got about 15 minutes, so let me see if I can squeeze in a few questions to help out while you're still here. But first off would be something from assignment 9. You should have done this one first. So other than the 4 that I already did for you, was there any of the others on assignment 9 that you felt like you wanted some help on? Yeah, I can. Okay, so on 6, I'm assuming you did the direct substitution, got 0 over 0. You went that far. You should recognize that this is a complex fraction. You don't have to know the name complex fraction. But you should know that you need to multiply all of these by, well, what's one thing we need to multiply them all by? Okay, we need to multiply them all by x plus 2 to make sure those cancel. And it's all or none. If you multiply one thing by x plus 2, everything gets multiplied by x plus 2. And then the other one you said was times 2, times 2, times 2. Okay, so did you finish this question and just get a different answer? Okay, I have a very strong idea about what happened. So right here, you're left with 2 times 1, which would be 2. Right here, did you say that you have a minus x plus 2 like this? Okay, it's minus all of that, so you got to make sure that you distribute that. That's going to be important. And then the denominator has the x that's been there, the 2 that I multiplied everything by, and the x plus 2 that I multiplied everything by. Because if you distribute that negative, now when you combine like terms in the numerator, the 2 and the minus 2 go away. Then you've got a times x divide x, so it cancels. And then of course, as soon as something cancels, you are just about done. And then that matches up with what they've got. So is that what your mistake was, the negative? Yeah. Very easy to do, especially in complex fractions, because this gets pretty chaotic and it's very easy to lose something. So unfortunately too, as a multiple choice question, if you do make that mistake and forget to distribute, that's probably one of the choices. If y'all are not aware of that, multiple choice questions should have the right answer and the most common 3 wrong answers. So I know you guys like multiple choice, it might make you feel better, but just because you see an answer in multiple choice doesn't necessarily mean that you should feel better about it. Could just be one of the common mistakes. Okay, is there another one I can work from assignment 9?
Could you also do
Number 9? Sure. I have this. Okay, on question 9, I'm assuming you plugged in the 0 and saw that you went to 0 over 0. Okay, doesn't factor, there's no square root, so it's not conjugates, but we do have fractions within a fraction. So let's deal with this complex fraction. Multiply this by 6 so that those cancel, and multiply everything by x minus 6 so those cancel. So if we do that correctly, again, you want to be very careful, just like the last one y'all asked about. This gets so messy that if you're not careful, you kind of lose stuff. I've got 6 times 1 plus 1 times x minus 6 over a 6, an x, and an x minus 6. Looks like this one's going to finish similar to the last one, because plus 6 minus 6 is just going to go to 0. And then the times x divided by x could cancel. And if we plug 0 into what's left over, negative 1/36. Is that okay? Anybody that was going to ask about number 9 have something more detailed than what I talked about on here? Okay, I'll offer one more question. I think we got time for that. Anything else you found on assignment 9? Okay, for those of you that have made it to assignment 10, is there one that you have found that you'd like to go over? Yeah, Brody? Number 3B. Oh, did you get an answer of 1? You didn't get an answer. Okay. The answer key has one of these wrong on here. I don't remember which one it was, but it's one of these type of questions. So if you're trying to take the limit of something, of a function with another function plugged in, this is where you want to do the outside part last and the limit of the inside part. Again, add, subtract, multiply, and divide works the way most people expect. But composition of functions like this is not intuitive for most people. So the only calculus part is going to the graph and looking at what as it approaches x approaches 1. Looks like it approaches -5 from the left and the right. So that would be -5. But then at the end of the question, now calculus is done, it just wants to know what's the y value when x is -5. So up here, when x is -5, y looks like it would be 2. 2 is what I would go with. Again, one of these has a mistake on the key. Those are not my answers or anything, but we can talk about that next class if you don't understand or if you don't catch it when you're working it. Okay, so to finish up today, we got about 9 minutes here. So you can go ahead and keep on going through your homework, but I've got 3 things I'd like to do with you real quick. First is I need to make sure you know exactly what your homework is, if there is homework. And I've said this already, but I just want to be clear. Number 9 needs to be finished. You really probably should have finished this one in class. And number 10 needs to be finished. Those are the 2 that I might take up on Tuesday. Also, you should have number 8 done. So I guess if you accidentally forgot to not finish that one, you got lucky. But there's a good chance I'll take up number 8 next class too, but it should already be finished. Number 11, you don't need to do anything else on. As always, if you forget what your homework is, especially since it's a long weekend and I don't see you tomorrow, tomorrow's an A-day, remember you just go to our class website. It's got this agenda in the top right. You can go glance at the homework box when you're at home. All right, secondly, this is one of my favorite math memes. I use this one every year. But can anyone explain to us the math behind it? Where the joke's coming from? Yeah, go for it.
It's inverse.
Okay.
So like the cat eating the fish and then the fish eating the cat.
Right, so function, the input might be the fish and the output might be the cat. And then inverse means you swap those two. So now the fish is eating the cat instead of the cat eating the fish. I like that one. Okay, and then finally, I've got not one more, I'm trying to do one of these type of things today. I've got another puzzle for you. I think we are on, you did the checkerboard one. What was the answer to that?
104, 106.
204, very good. Did you do the sock one? All my classes are at different spots. Okay, so go ahead and keep on working on your homework, or if you want to give today's puzzle a chance, give it a shot. Somebody in one of my other classes complained that this wasn't so much a puzzle and just math, but I still like it. What's your answer?
50%.
Wrong.
Is it 112?
1/12? Is that what you said?
1/4.
Am I close?
It's a good thing this is an AP stat. I'll be in trouble. It's close to 50%. What'd you say?
11 and 48.
Nope. Nope.
You said it's close to 50%?
It is close to 50.
You pick one stock, that's nothing, and then you pick another one, it's like 50% chance.
Oh, you have to. There's no replacement. Or no, it's
Yeah.
It's 11 and 46. Okay,
You're close.
1/2 times.
Okay, so when you pick the first sock, what's the odds that you get a sock?
100%.
100%, right? You don't care what you get the first draw. But then once you get your first sock, it's either black or white, and then your next one needs to be the same thing. So on your second draw, how many of that sock color are left?
11.
Out of how many could you pull from?
23.
So the odds of you getting two of the same is 100% times 100% is just one. 11 over 23. 11 over 23 is about 48%. Now, Johnny, if this was with replacement, if you ever do a math class that does more statistics, like if you took the first one out, saw the color, if you replaced it and put it back in and redrew, then it would be 50-50. But we have to assume that the first one's taken out and out of the pool, so.
I like that.
Okay, you're down to about 4 minutes, so find a stopping place.
Which one did you say was in? I feel like you had wrong information.
I don't know, they're not my answers. It's one of these that's a function plugged into another function. I want to say the answer was one, but then the answer for this is different. It might be this one, I'm not sure. I gave you all that warning, so if you see a different answer when you check the answers, I don't want you to spend 30 minutes trying to figure it out. You can just ask next class.